Example 7. At a sand gravel plant, sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. So rate 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. At what rate is the height of the pile changing when the pile is 15 feet high? Alright, so we got a conical pile. Okay. And let's see. The sand is falling off the conveyor onto a conical pile at a rate. So we'll say dV, this is volume, dt equals 10 cubic feet per minute. So feet cubed per minute. The unit here will indicate whether it's volume, area, or distance. If it's squared, it's area. If it's cubed, it's volume. If it's just feet, then it would be the distance. The diameter, so we got the diameter here. The diameter, this is the height, that's the diameter. The diameter of the base of the cone is approximately 3 times the altitude, which is the height. They want us to find at what rate is the height changing with respect to time when the pile is 15 feet high. So when h is 15 feet high. Alright, now what we need to do, we've got volume and h. We need to come up with a formula that involves this cone, that involves the variable v and h. So the volume of a cone would be 1/3 pi r cubed times the height. I'm sorry, pi r squared times the height. Okay, so now if we take the derivative of this volume of a cone formula with respect to time, we'll have these rates that are related to each other. But notice here, we have v, which is fine, we have h, which is fine, but then we also have a third variable r, okay, which, since we don't have anything that tells us the rate of change of the radius with respect to time, we need to see if we can substitute that out with something. Well, this piece of information here, we know that 2 times the radius is equal to the diameter, so my radius is equal to 3/2h. So now what I can do, I can substitute this formula. So I got v equals 1/3 pi, or I'm going to replace that with 3/2 h, and I still have to square that times h. So this would be 1/3 pi. If I square 3/2 h, that's going to be 9/4 h squared times h. So this is going to be equal to 1/3 pi 9/4 h cubed, and then 3 goes into 9 3 times, so this is going to be 3/4 pi h cubed. So now what I can do, I can take the derivative of the volume of the cube and I can represent it as 3/4 pi h cubed. Okay, and I'm going to take the derivative of that with respect to t. Okay, hopefully you can see how this formula and this formula are equivalent to each other. We just represented h in a different form. Okay, so now we can take the derivative because all we have is variable v and h. You take the derivative of v with respect to time, that's going to be dv dt. Okay, and then here, this is going to be the power rule. So this would be 3 times 3/4, which would be 9/4 pi h squared. And then we took the derivative of h with respect to t, so this is going to be dh dt. Now, we want to solve dh dt. We know dv dt is 10. We know h is 15. And dh dt, that's what we're trying to solve for. So now I got 10 equals 9/4 pi. 15 squared is 225 dh dt. Then I'm going to go ahead and divide both sides by 9/4 pi times 225. Divide both sides by that. So now I got 10 over 9/4 pi 225 equals dh dt. And now I just have to simplify some. So let's see. 5 goes into 10 2 times, and 5 goes into 225 45 times. So now I have 2 over 9/4 pi times 45 dh dt. And then what I would do, I'm going to multiply the numerator and the denominator by 4. So the numerator is going to end up being 8. Then I'm going to have 9 times 45, 9 pi times 45. And now I have to do 45 times 9. 9 times 5 is 45. 9 times 4 is 36, plus 4 is 4. So this is going to be 8 over 405 pi. This, and let's see, this is the height. So this is feet per minute. Make sure you give me the answer in an exact form, not a decimal. So never give me a decimal answer unless I specifically say, give me a decimal answer, or round to the 10th place, something along those lines. If not, give it to me as the exact answer.